So welcome back, depending on when you're watching this. For me, about 2-3 minutes to help me get set up for the next lesson 8.1.2. For you guys, could be a couple hours or a couple days, or you guys are frantically watching these on Thursday night to finish the quiz by Friday. Your choice. It's all up to you. Hopefully that isn't the case, and let's begin. So we're gonna look back at the work you did in problem 8-2. It's fresh in my head for me. 8-2, 8.1.1, about degrees and how many real roots. This is all about how many real roots there are, sketch an example, and we're gonna be figuring out how to make more accurate sketches by just the real roots we have, which are the x-intercepts. Remember, real roots are the x-intercepts. Yeah, I'm reading from what's above in the directions, but this is important. What is the maximum number of real roots a polynomial of degree 3 can have? We know that a third degree changes 3 times, but if there's a squared, it can have less than 3 real roots. But the max it can have is 3 real roots. Hopefully we realized that when we were doing yesterday's lesson. So if I bring back the first page right here, we can tell that this one has 2 real roots, even though it's degree 3, and this one has 3 real roots, even though it's third degree. So we can safely say, I moved the paper, we can safely say that the max number of real roots a polynomial of degree 3 can have is 3. 3 real roots. Because I want people to understand what I'm writing. And now we just need to sketch an example. Here's my x and y, doesn't matter. All I needed to make sure is that my graph crosses through the x-axis 3 times. Not touches, crosses. 1, 2, 3, there we go. Perfect. Good to go? Let's do the second. Let's do B. What do you think is the maximum number of real roots a polynomial of degree n can have? So if it's x to the n instead of x to the third power, what is the maximum number of real roots? It's going to be n number of real roots. So whatever n is the maximum number of real roots you can have. So if it's degree 6, you can only have a 6 number of real roots. If it's degree 1,364,732, well, you can only have, I honestly forgot the number I just spouted out, but that's the number of real roots you can have. Doesn't matter. You can go on to infinity. That's it. Doesn't even want us to sketch. Good to go. Can a polynomial of degree n have a fewer than n real roots? And we learned about this. Yes, it can. When it's under the, what was it called in the last section? I also have to reference the double root. Right here, the double root. So, yes, if it has a double root. That's how we know that it can have fewer than n real roots. One of the ways that we know so far. There might be more, there might not be, but you know, future you can worry about it. Now you's gonna worry about this. Examine the sketches below for each polynomial function below. State the minimum degree you can have and explain how you know. Well, the explanation is going to be the same, so you don't have to explain the same thing 4 times. You can just do it on the first one. So let's do the first one. All right. 2 bumps. Is it 2 degrees? No. It changes direction how many times? 1, 2, 3. Third degree polynomial. And how do we know this? How many times it changes? Number of times the function changes directions. And we can also state, we can go further. We can state that it's odd because it has opposite end, what was it called? My God, me and words today. Just not having a good time. End behaviors. It has opposite end behaviors. That's why we also know it's going to be an odd. So third degree is an appropriate answer. What about this one? Same end behavior. It's going to be an even. So it goes up once, then down a second time. So it'll be second degree. Same explanation. You don't need to write it out again. We're good to go. How many times does this change direction? But before that, even or odd? Even. Same end behaviors. 1, 2, 3, 4. Fourth degree. And you can write degree ... 4. Yeah, it's your choice. Whatever you want. Colon 4. All right. What about this one? You know it's going to be odd because it has opposite end behaviors. 1, 2, 3, 4, 5. Fifth degree. All right, that's that for that one. So let's do 8-27. All right, so this is asking us to sketch the function based off of the number line. No, this isn't like shading or what we've done before. This is different. If it's not shaded, then it's going to be above the x-axis. It's going to be in the positive region, above the x-axis. If it's shaded, I think I mixed it up. Never mind. If it's not shaded, it's going to be negative. It's going to be below the x-axis. If it's shaded, it's going to be positive. It's going to be above the x-axis for this part of the graph. And then if it's an open circle, it's going to state the real roots. It's nothing like the number line that you guys are used to doing. This is different, and if we're going to switch it up on you guys, we will tell you. We're not going to send you into an exam and be like, oh yeah, I guess if we meant this way or that way. No. Well, I might because I'm devious and I just want to watch you guys fail. Kidding. I don't want to watch any of you fail. So let's start by plotting the real roots. So we know it's -3, 0, -1, 0, and 4, 0. So -3, 0, it's somewhere over here. I'll label my points afterwards. I'm not gonna do it now. I don't want to cross over what I labeled. -1 is gonna be over here, and then 4 is gonna be a little bit further than, if we plot a -4. But after we graph this, it also wants us to write a possible equation. A possible equation doesn't mean it has to be the exact equation. So don't worry about that. Just write what you think it's going to be. So we know that it starts from the negative until it hits -3. So it's going to start off down, going downwards. Then it's going to go positive because it's over there. And if you want, you can write negative, positive, negative, positive to show which parts of the number line are negative, which parts are positive. And then we can do the same for the second one. But we'll worry about that then. So let's go. Going up, it crosses through again, right? Yes, it does. Then we're going to come back. And we know that it crosses through 4 because it goes from negative to positive. And there we go. So now how can we create a function? So I'm going to write p of x. You're going to use whatever, q, s, t, v, w, doesn't matter. But first we have to figure out, is the leading coefficient a negative or a positive? It's odd, but it starts from down, goes up. So if we bring back that page where we figured out whether its leading coefficient is positive or negative, right here, right? So it's odd, it goes from down up. So it's right there. It's positive. It's a positive. We don't need to worry about the orientation. We're good to go. So then I know it's x plus 3 times x plus 1 times x minus 4. That's it. Because I need a -3 in here to get negative 3, 0. I need a negative 1 here to get a negative 1, 0. And I need a 4 here to get 4, 0 for my x-intercepts. That's it. Good to go. Let's do the second one. Let me move this out of my way so I can focus on, well, that table is important to have to reference, and I'm not going to reference it for this one. So if you guys want to fact check me, you guys should reference it for yourselves, but I have already done this, so chill. Got this. So let's start out by writing on the number line. Negative for this part, positive, positive, and then negative. So we have a double positive. Does that mean that the line that the graph is going to cross from this section, is the graph going to cross into the negative region, or is it going to just touch the x-axis? Correct answer, it's going to touch the x-axis. So what can we tell about this section? Yes, it's a double root. X to x plus 0 is a double root, which means it's just x, because x plus 0 is just x. Right? So let's graph it. Negative 5. Oh, I forgot to write my points in the last one. So let's do this. Negative 3, 0. Negative 1, 0. And 4, 0. Right. It's important to label your points. I forget because I am a forgetful person. Not because it's not important. It's definitely as important. 0, 0. And 2, 0. Negative, so it's going down on the first end. Then it goes, crosses through into the positive. It's gonna touch the 0. It's gonna come back up, and then it's gonna come back down to hit the 2 and go down into the negative. So what is it going to be? It's going to be 4th degree polynomial. That's why it's a double root at x equals 0. Now what's my other question is, what's the leading coefficient? Leading coefficient is a negative because it's even and it's going down, down. So I'm going to write negative, and I'm going to start, well, first I got to state what we're finding, and I'm going to do s of x equals, because it's a equation, it's a function. I can't just write that, then it's an expression. So I'm going to write negative x squared to account for the 0 times x plus 5 times x minus 2. If you look over there, you do the math, you'll get a 4th leading coefficient of degree 4. And that's all you have to do. Alrighty, let's do the next page. So it's asking us to do the number lines for the following functions for this part. So if we do the first one, it has a double root and x plus 1. So what degree is it? 3rd degree. But we can just write the roots. So I'm going to do open circle to indicate my roots. That's all I need. I'm not going to include 0 because then it'll just confuse or mess me up, because I created an open circle to show that it's a real root. I don't want to get confused and think that 0 is also a real root. So if we go left of negative 1, it's going to be negative. So I don't need to highlight that, but everything else is positive. So I go from positive to another positive when I hit 3 because it's a double root. That's it. That's all I have to do. Let's do number 2. What is my leading coefficient? What is my degree? You have x times x, x squared, times x, x cubed, times the other x, x to the 4th. Right, that's it. So now let me write my number line. I have negative 3, negative 2, 1, and 2. I can use this, or I can use that to find my real roots. Choice is yours. Negative 3, negative 2, 1, and 2. Yeah, that gap is it's fine. So it goes from positive 2 negative, so I don't need to worry about highlighting there. 2 positive, 2 negative, no need to highlight there. 2 positive. Are there any double roots? No, because I'm not going from positive, positive, or negative, negative. Everything is going from positive, positive, negative, positive, negative. There's no two same signs next to each other. So we're good to go. And the graph also tells us we're right. And so does the function. The function doesn't have any double roots. So we're good to go. All right, hopefully you guys will try number 3 before I do it. I hope you're comfortable enough to do this on your own. So let's start. Where are my real roots? -3 and 0. Do I have a double root? Yes. Where? Right at 0. So let's start with left of -3. It's positive. Highlight. Do I need to highlight anymore? Or shade, or whatever. I should have called it shading. Words are hard. Do I need to do anything else? No, that's it. I'm done. I am good to go. All right. Ooh. Let's do 8-31, number 1. Without using a calculator, make a number line and sketch graphs of the following functions. So what do you think is going to be easier? Doing the number line first and then sketch graph, or sketching the graph and then doing the number line? I'm going to do the number line first because then I can see it, whether it's a negative or positive on the left end or right end. And then I can sketch it out. And to do that, I'll need to reference that. Is this it? Nope. To reference the table that was done in the last lesson. You reference that table to figure out leading coefficient, negative, odd or even degree, odd. So if it's an odd and a negative, it's gonna start by going up and it's gonna end by going down. So I'm gonna do -1, 0, and 3. That's it. Good to go. So I know that it goes up on the negative because of my leading coefficient, and it's to the 3rd degree as degree 3. I did it the other way, show you guys that you can. Then 0 is my other root, and then x minus 3 is the last one. So then I have no double roots. So this should be positive, and then it will end in the negative. So let's do it. -1, 0, and 3. Make a dot for 0. So it starts up, positive, crosses through, it doesn't touch it, crosses through, go back up through here, come back around, and it crosses through. It crosses through at every point. It doesn't touch at any single point because it's there's no double roots. All right, so let me label my points. -1, 0. This one is easy, 0, 0. And 3, 0. Good to go. First time I didn't forget labeling my points. Yes. It's the small things. Small things. I'm trapped indoors all day. Give it to me. All right. So let's do this one. To the 3rd power. This one's going to be funky. It really will. But let's start out with what we know. I'm going to do the number line first because it makes the most sense to me. I don't know what happens with degree 3. So let's do it. -2 and 4. So if I look back onto that table, I know that it's degree 4. So it's even, and I know the leading coefficient is positive. So it's going to be positive on this end, and it's going to be up. It's going to be up, up. So it's going to be positive on both ends. It's going to go up positively. So it's going to be up, up. So I'm going to go -2, somewhere around there, and 4, somewhere around there. So since I know it's going up, right there. I'm gonna need to make two more directional changes to get to 3 before I climb back up. And yes, you can find the y-intercept, which might make it easier. So let's do that. If we have p of x, we know that the y-intercept of the last one is 0, 0. I forgot to mention that. So let's just find the y-intercept of this one. P of x equals 0 plus 2 cubed plus 0 minus 4. And we will get, I'm surprised I didn't do this one. We will get 2 to the power of 3 times negative 4, negative 32. So the y-intercept is 0, negative 32. So I'm going to make an arbitrary point of 0, negative 32 down there. But I don't know whether that's the minimum or it just keeps going and it just crosses through that point. So I'm going to make one directional change over here. And then I'm going to keep going down and then make another directional change at that point. And then I'm going to bring it back up. So I have 1, 2, 3, and then 4 when it goes back up. So it's gonna look something like that. And I made it like this because it's to the 3rd power. And I do know that hyperbolas look like that. Cubic functions, you know. Yeah, 0, I'm going to put the parentheses. And now let me label my points. I'm going to label that 4, 0, and negative 2, 0. There we go. So, if you have any questions, we will be seeing each other this week. Let me know if there are anything that I was a little bit confusing on. Let me know, give me feedback so I can improve these videos as they go as well. Thank you, and I'll be seeing you in the next lesson.